inverter is nothing but it is the circuit which is converting DC to AC. Okay. Which is giving only 50 hertz, which is giving the 50 hertz signal. It is not. It will not give 50 hertz signal. Okay. So may in that it varies
Your
frequency.
sound is breaking, sir.
Less frequency from few hertz
छोटा
to
आवाज.
it may, yeah, it may vary from few hertz to few kilohertz. Okay, so that is the inverter. Now we have seen series inverter. So depending on the type of the commutating components, you are connected with the load. Whether load is in series with the commutating components or whether the load is in the parallel with the commutating components, we can say a series inverter or whether it is a parallel inverter. Okay, so yesterday we have seen the basic series inverter in which you can see L1 C1 it is connected in series with the RL load. So what is the basic drawback of the basic series inverter we have seen? Here we can see the frequency cannot be increased beyond a certain limit. Okay, so why the frequency cannot be increased beyond a certain limit? The frequency cannot be increased beyond a certain limit. The reason is that there is a need to provide some T of time or the rest time, right? You cannot start the negative half cycle, right? At the same time, positive half cycle ends. You can see here, right? This gap is there. Can you see this gap? Okay, we are providing this gap. We are providing this gap just due to so that to avoid the short circuiting of battery. Suppose assume करो कि मैंने I am triggering this SCRT2 at the same point. You can see this pointer or the mouse. What will happen? There is a chance that means if SCR1 is not turned off properly and SCR2 is again you are turning on, what will happen? There will be short circuiting of the DC supply. That may occur. And that's why to avoid the short circuiting of the battery, right, you are providing this gap, right? This is an important drawback of the basic series inverter. And as far as another drawback is concerned, this another drawback is the battery is providing only positive half cycle, not the negative half cycle. Correct now? Hello? Battery is providing only positive half cycle, not the negative half cycle. Okay, and due to which there is a poor regulation as well as there are the high percentage of harmonics in the supply current. Understand? Because supply current is present when SCR1 is on and supply current is absent when SCR2 is on, isn't it? And that's why the battery is acting intermittent in nature, and that's why we have to go for the circuit called as a modified series inverter. So I asked you to draw this. Hello students. Yes, are you there?
Yes, sir.
Hello.
Yes, sir.
Yeah. Okay. Draw the circuit, students. I using the WPS office for the annotation purpose. Right? In PPT, I can go for the annotation, but for PDF, that's why I downloaded this WPS office with the help of which it is possible. Right? Wave line. Okay. Okay. So now, if you have drawn the waveform, I may go for the modified series inverter. Okay. What happens? So basically, using the circuit, we are going to increase the frequency. You are going to increase the frequency. Means what I explained you here, there is no need to provide the gap. You can see in the earlier circuit because there is a short circuit of the battery may occur. And in this case, if you are trying, suppose this situation arises, so there will be no short circuiting when SCR2 is triggered before the triggering on of SCR1, right? The SCR1 will be triggered off. That is the purpose of this. How it works? Now listen. At the instant when SCR2 is triggered, the voltage across the capacitor will be slightly less than the EC plus ADC, okay, and the load voltage and the current will be close to zero. So it is slightly less than or approximated to EC plus ADC, and the load voltage and the current will be close to zero. So earlier you have seen that this waveform, right? Here you can see my load voltage is zero. You can see as well as my this load current is also become zero in this part. Okay, so load current is zero and the load voltage is zero. Okay, now so here load voltage and current will be close to zero. Hence, the voltage across the capacitor minus the load voltage will appear across L2. Now, if you see, according to the superposition theorem, what will happen? The load voltage across the capacitor minus the load voltage will appear across the L2 since L1 is closely coupled. Now, what is by coupling? You know that when there is a, because transformer works on the principle of coupling. Actually, you are passing the current through primary coil or primary winding of the transformer, but EMF is induced in the secondary. Understand why it is happening? Due to the coupling. Understand? And how much percentage of the voltage will be appearing across the secondary of the transformer depends on the coefficient of coupling. And coefficient of coupling depends on the medium which is used, right? Or I can say it is depending on the core of the transformer, right? Whether it is iron core or whether it is air core and all. So ultimately, the it is depending on the when it is closely coupled, the same voltage will appear across the L1. Okay, so here the voltage across the L2 and L1 will be same, that will be appearing across the L1. Now, the voltage across the L1 will tend to increase the cathode potential of SCR-T1. Now you can see this is the cathode, this is the cathode of T1, right? So this is the cathode, right? And here is the anode. Okay. So what happens in this case? What I mean to say, when voltage across the L1 will be appearing, then the voltage across L1 will tend to increase the cathode potential of SRT1 more than its anode potential. Now ultimately, you know that when the voltage at the cathode potential is more than the voltage at the anode potential, what will happen? The SR-T1 will be reverse bias. Understand? Voltage across SCR-T1 will be reverse bias and turns off, right? What I mean to say that it means that I don't know. Okay, so thus even if SCR-T1 is turned on, SCR uh, sorry, thus even if SCR-T2 is turned on before SCR-T1 is switched off. अभी मतलब कैसा है कि if there is a such situation occurs, means both the SCRs T2 and T1 is turning on at the same time, so it will avoid the short circuiting of DC source. Understand? अगर मैं क्या कर रहा हूँ, if this is happening, right? So ultimately, if T2 is turned on, if this is on, and before that this is also on. If this is on, then ultimately this will be short circuited for 30 milliseconds. So if this is on, then ultimately this will be
Sir, can't hear you. Lost the voice signal. Can see your screen, but cannot see your voice. Cannot hear your voice signal.
EMF across the L2 will be the same. Hello.
Yeah, hello.
Sorry, there was some network problem. That's why I got disconnected.
Yeah, sir, I
Just
can I can
wait now.
understand.
Okay. Now, is it visible now? Hello?
Mm,
Yeah,
sir,
Vignesh?
yes, a presentation has started, but I'm not able to see your computer screen.
Okay. Okay. Yeah, just wait. It will be appearing. Okay. Now?
Mm, sir, at least not from my side. I'm not able to see. I will do one thing. I
Okay.
will
Okay.
reload. I will
Just
reload.
wait.
I will rejoin
Yeah.
you.
Yeah, just wait. But any other students can tell me whether it is appearing now? Hello? Any other? Minal or someone else?
No, sir.
Yes, sir.
Yes,
Is
sir.
it
Yes,
is it visible?
Yes,
yes,
sir.
sir.
Visible.
Is it
Yes,
visible
sir.
better?
Yes, sir.
Yes, sir.
Okay, thank you so much. And sorry for the trouble. Yeah. So what I meant to say that the modified series inverter, what we are saying, what is basically it avoids the disadvantage of increasing the frequency. Now, when it is happening, when the thyristors are turned on, Now listen.
Yes, sir.
Yeah, yeah, yeah. So this is the another kind of the modified inverter, I would say, right? In this, huh, bolo. So in this case, here the intermittent nature of the inverter, what I mean to say that already I explained you, the positive half cycle is provided by the battery and the negative half cycle is provided by the capacitor, isn't it? So that is called as the intermittent nature of the supply, and that can be avoided using this kind of the circuit. Understand? This can be avoided using this kind of the circuit. Basically, in this circuit, what is happening over here? The part, if positive cycle is there, 50% is carried out by the or supplied by the battery, and 50% is supplied by one of the capacitors. Similarly, in the negative half cycle, 50% of the current is supplied by the battery, and again the remaining 50% is carried out by the another capacitor. Now try to understand what I'm explaining. As in the basic series inverter, what was happening? In the hello, am I audible, beta? Hello?
Yes, sir.
Yeah. So what is happening earlier in basic series inverter, not the earlier circuit, the positive half cycle is provided by the battery and negative half is provided by the capacitor. So it is very dangerous. It results in poor regulation. So what is happening in this circuit? In every half cycle, bat one 50% carried by the battery and 50% carried by the one capacitor. In negative half cycle also, 50% will be carried out by the battery and 50% will be carried out by the capacitor. That I mean to say. Okay. So here, okay. Now listen. Basically, how this circuit works. Now, now here, when T1 is triggered, now ultimately these two C1 and the C2, C1 and the C2, it is triggered. C1 and C2 are connected in parallel, and as the values of C1 and C2 is exactly uh, same, right? Here the voltage across the C1, it will be, suppose if you assume that this voltage is Vs, isn't it? So it will be Vs by 2. Why it is changing? Yeah, a minute. So this will be Vs by 2. Okay, just wait. And here also the voltage across the capacitor, it will be Vs by 2. Is it okay, students? Okay. Hello. Yes. Are you agree
Yes,
with
sir.
this?
Yes, sir.
Because my applied voltage
Yes,
is
sir.
2. Yeah. Okay. Fine. Now, as you know, the here the T1 is triggered initially. So when T1 is triggered, right, what will happen? There will be currents flowing, right, in the path. Okay. So what will be the one current flowing in the path? So later I am drawing the one path of the current. Please listen very carefully, students. It is starting from the positive of the battery, isn't it? Dekho,
Yes, sir.
positive of the battery. I am showing with the arrow like this. Then back to the T1. Okay, students. Okay.
बराबर
Then,
बराबर.
yeah, then it will go to the R.
हाँ,
Okay. The current will flow through the R. And after that, current will flow through the C2 like this and back to the EDC minus. You also write down in your notebook. We draw this circuit first, students. Hello. Draw this circuit.
drawing, sir.
Yeah, please. Okay, now listen. Okay, now let me clear one correction in this circuit. This initially, right? This will be negative and this will be positive. Okay. Now here let me clear. Now some of the voltages across C1 and C2 will be EDC. As it is negatively charged, this C1 will be charged initially to the EDC plus EC. You may not write down. Whereas with upper plate positive and lower plate negative. Whereas some of the voltages should be EDC, cannot be more than EDC. So I will say this capacitor initially will charge with the voltage minus EC. Okay, this is initially, this is my situation. When suppose if I am now applying this voltage Vs, this is my current flow. Are we agree with this one current? This is wrong in this circuit diagram. This will be positive, negative and positive. This is the situation. Okay. So this is a what happens here. I would say that will charge the capacitor C2. Okay, that will charge the capacitor C2. Whereas what will happening to the capacitor C1? Will anybody tell me? I will say charging of capacitor C2 is taken place in this direction of current. Is it clear? So this is charging of C2. Okay. Whereas discharging of C1 will taken place. Everybody agree? Discharging of C1. Okay. Now, what is the path of discharging? Right? The capacitor will discharge in this path, right? In this clockwise direction. So every time there will be two currents will be flowing. One is through the load and one is the discharging of capacitor C1. Okay? Are you agree? Hello?
Yes,
Yes,
yes, sir.
students?
Yes, sir.
Huh. Yeah. Now see, both the currents, if you see, they are flowing from right hand side to left hand side. Are you agree? Everybody? Yes or no? So this below direction of current is provided by battery. Are you clear? See, arrow is showing like this arrow. Whereas the above current is supplied by the capacitor. Are you okay? So what I mean to say that in this case, the current is provided, 50% current is provided by the battery by this arrow you can see in this path, arrow means by this path, whereas 50% of the current is provided by the capacitor C1. Is it okay? Hello students. Yes,
Yes,
everybody agree with me?
yes,
Yes,
sir.
sir.
Yes, sir.
Yes, Minal, Sakshi, Ritesh, Vinay, Vivek, Jayesh, Vignesh. हाँ बोलो Sujit, any doubt?
No, sir.
Please, please.
Sir.
Okay, fine. So are you agree with this now? 50% of bolo, doubt, any doubt? You may ask anytime. What I mean to say that 50% of the current is provided by the battery and 50% of the current is provided by the capacitor C1. When current is flowing from positive to from right hand side to left hand side. Is it clear? Okay. Next one. Another one. Now, while discharging, what happens? This capacitor will discharge to the value of negative EC. Okay, students, right? And when it's charging, this capacitor will charge to the ADC plus EC. Hello, students. Are you agree?
Yes,
When it is
sir.
charging, it will charge to EC plus EC, and when it is discharging, it will be discharged to negative EC. Means what is happening beta now? Here, this current will be plate above plate will be negative positive. Are you agree? You should be agree, right? And now this negative positive will change to positive negative. Please listen very carefully. Positive and negative current, right? So negative EC, negative EC we will say with upper plate negative, bottom plate positive, whereas the capacitor C2 which was at minus EC will be charged to EDC plus EC, means upper plate positive and lower plate negative. Are you okay? Okay, clear. Now what happens? Right? Now with this T1 stops conducting when current through the T2 goes down to zero. Is it clear? ये इतना समझ में आएगा बेटा आपको? Yes, everybody. At the end of this cycle, अगर आपने देखो मैंने CRO यहाँ पे पॉजिटिव लगाया, यहाँ पे नेगेटिव लगाया, राइट? I will get the current waveform like this. उसमें कुछ ऐसी बड़ी बात नहीं है. Finish. Okay. अभी क्या होगा? ये T1 जो है ना मेरा, T1 will mutate, means it turned off like this. ये बंद हो जाएगा. Now T2 is triggered. मैंने क्या किया? T2 is triggered means this is acting as completely short circuit. Equivalence अगर मैं बात करूंगा, this is short circuit. Now current should be reversed, no? Hello, yes or current should be reversed. Now what will be new path? अभी मैं ये थोड़ा रव करूँ तो क्या समझने के लिए? Otherwise it will be some mix up. Hello students. Hello. Shall I remove this for time being? Otherwise it will be confused. I will now explaining you the negative direction of current, ultra direction of current. Shall I remove for the time being? Erase for the time being? Hello?
Yes, sir.
Is it
Yes,
okay?
sir. Yes, sir.
हेलो मैं रिमूव कर देता हूँ आपको ये समझ में आया ना एक साइकिल कैसे मिला नो आई विल रिमूविंग फॉर द टाइम बिंग मींस अदरवाइज या पूरा एक साथ अगर मैं लिखूंगा ना कंफ्यूज हो जाएगा दैट्स व्हाई ओके जस्ट आई विल रिमूव इट अदरवाइज ओके ठीक है स्टूडेंट्स अब देखो हमारा एट द एंड ऑफ दिस साइकिल व्हाट वाज माय सिचुएशन मैं बोला था ये नेगेटिव और ये पॉजिटिव विद द नेगेटिव ईसी एंड जस्ट नाउ आई सेड दिस इज पॉजिटिव एंड नेगेटिव ओके विद द वोल्टेज अक्रॉस इट इज ईडी प्लस ईसी ओके फाइन ईडीसी plus EC. Now T1 is turned off at the end of this cycle. Okay. Now again negative half cycle should be provided. So I am writing here T1 was conducting. ठीक है इसमें क्या हुआ 50% of the current provided by the battery and 50% is provided by the C1 that I explained to you. Now when T2 is triggered, my current from the battery will be provided in this path. Listen students very carefully, it is very interesting. Like this. See, I am drawing the path over here. Please see, like this. Current will be always supplied by the positive of the battery, like this. Okay. What happens here? This capacitor will be charged from negative EC to EDC plus EC because from negative positive we are getting the current. Capacitor getting the current. And another current will be provided by the charge capacitor C2 in this path. Are you agree, students? Okay, clear, students? Okay, now direction of current is changed from left to right. Can you see? Hello, students. Yes or no?
Yes, sir.
Hello. Now change. Earlier was direct. What was direction? It was from right to left. Now what is the direction from left to right? So I can see some gap people are providing as such. you are taking care of due to these inductors. So I'm not showing some gap over here, and this is my waveform for when T2 is triggered. It is negative half cycle. Is it clear now to you? Hello? Yes? Any doubt? So earlier, what happens again during this process? My capacitor will be charged from negative to positive negative, और जो पहले से positive negative था, again it will go to from negative positive. Means it is as good as the initial condition from which we started, isn't it? So from minus EC, again it will go to EDC plus EC, C1, and C2 will go to the minus EC, as good as the my initial condition. So you can see the positive half cycle is provided by the battery plus C1, whereas negative half cycle is also provided by battery and the C2, right? So here I am writing here C1 plus battery, C1 plus battery, and here also it is C2 plus battery. Yes, students, is it clear now? Yes, everybody? Any doubt here? Right? So with this circuit, we remove the drawback of intermittent nature. Right? In earlier circuit, we have seen the increase in frequency can be, but this is combined circuit. As we are using here inductors, that earlier drawback is also removed. So this is my final modified series inverter. Just with means dividing the working of the circuit by explaining the removing of two disadvantages. One is removal of increase in the frequency can be done, and second is intermittent nature of the battery, right, is removed. Any doubt here, please? You may ask. Hello, students. Clear?
Yes, sir.
Okay. So in next lecture, we will be studying parallel inverter, right? This is a parallel inverter and uh, some half bridge and full bridge if time permits. Okay. So first we will try to cover the parallel inverter in next lecture. Okay. I will stop here and just wait for the attendance. Is the attendance sheet is visible to you, everybody?
Yes,
Yes,
sir.
sir.
Hello? Yeah. Today is 10th, if I'm not wrong.
Yes, sir.
Yeah. Shivani is there? Shivani? Shivani?
Yes, sir.
Okay. Hitesh?
Present, sir.
Hitesh? Yeah. Vanita?
Present, sir.
Okay. Hemali?
Present, sir.
Nikita?
Present, sir.
Kiritesh Shrivardh?
Yes, sir. Present, sir.
So you go through the, I will share these notes. Okay. Please go through the whatever I will be sharing, because if you're not going through it, or if you're not reading, no, in coming lectures it will be very difficult to understand. Okay. Sakshi?
Present, sir.
Yeah. Pranil? Pranil More? येत नाही तो. परेश मुनी, परेश परेश नाही आहे. सौरभ,
Present,
सौरभ
sir. Present, sir.
या. उमेश पाटील,
Present, sir.
या. मिनल पवार.
प्रेझेंट सर.
तुला समजलं का आजचं सर्किट?
हो सर.
हा. प्रतीक राणे,
Present, sir.
दर्शन, दर्शन नाही आहे. प्रद्युम सावंत, सावंत. विनय शर्मा,
Present, sir.
विवेक,
Present, sir.
या. साक्षी शिंदे.
प्रेझेंट सर.
प्रोजेक्टचं काम चालू करा. अनुराग शुक्ला.
सर परेश मुनी प्रेजेंट.
ओके ठीक है, मैं करता हूँ एंड में. अनुराग, अनुराग. ओके. विष्णुकांत,
Present, sir.
जयेश,
Present, sir.
सुमित यादव, सुमित, सुमित नहीं है. हाँ, विघ्नेश आहे.
प्रेझेंट सर.
सुजीत,
Present,
सुजीत.
sir. Present,
Please
sir.
out loud, Sujit. Why are not asking this time? Okay. मोहिते वैभव, मोहिते. दुर्गेश.
Present, sir. Present. Present.
Oh. हाँ. अक्षय चौहान, अक्षय. अपसेट. मुनि परेश का करना है ना. Okay. I did it. So, any doubt?
थँक्यू सर.
You may any doubt. If you have, you can ask me right now. No issue. What I taught today, right? Otherwise, if you want to leave, you may leave. But जिसको doubt है, they can ask me right now what I taught to you today. जिसको doubt है, मेरे को अभी भी पूछ सकता है. I'm not in hurry. ठीक है? Okay, fine.
थँक्यू सर.
या.
Nice day.
विघ्नेश तुला काय डाऊट आहे?
नाही सर, आता तरी नाही. काही असेल तर सांगतो. हा सर, पण मला एक डाऊट आहे. मी तुम्हाला इथे सांगतो. डाऊट नाहीये, पण हा एक टेक्निकल प्रॉब्लेम आहे की जो
बोल ना.
आम्हाला जे रेकॉर्डिंग जे तुम्ही ह्याच्यामध्ये दाखवत होते ना, आपलं आमचं जे पर्सनल ह्याच्यामध्ये जो मेल आपलं कॅलेंडर मध्ये आम्हाला जे रेकॉर्डिंग मिळायचं ना, ते
हा.
तसं होत होतं, पण ह्या इथे नाही होत आहे. आमच्या ऑफिशियल याच्यामध्ये
नाही,
कॅलेंडर
मग मी काय
मध्ये
करू शकतो आता, आमचं ऐकून घे. आम्हाला जो लेक्चर संपतं ना, त्याच्या थोड्या नंतर एक मेल येतो गुगलचा, बरोबर आहे? तो मेल जर तुम्हाला मी शेअर केला ना, तर तुम्हाला मिळू शकेल. राईट?
ओके
मी
सर.
तुमच्या क्लासरूमला तो मेल शेअर करतो. मला मेल येत असतो. प्रत्येक पूर्ण मेल पाठवून देतो तुम्हाला, तर चालेल का?
चालेल सर, मला हरकत नाही. मला तरी पाठवा.
नाही, मी
मला
सर्वांना पाठवतो ना, मला काय प्रॉब्लेम नाही. मी सर्वांना पाठवेल. ज्याला बघायचं तो बघेल, ज्याला नाही बघायचं तो नाही बघणार. बरोबर ना?
ओके सर. ओके, हरकत नाही सर, हरकत नाही.
हा, तर मी तुमचा ग्रुप मेल आयडी तुला माहित आहे का?
ग्रुप मेल आयडी सर नाही,
मी
मला नाही
बघतोय.
माहिती.
ठीक आहे, मी पाठवतो तुला. ठीक आहे, आपण काय करूया, मला सांगशील मिळालं की नाही फोन करून. ठीक आहे?
हो
तेव्हा
नक्की
तू
सर. मग
टेक्स्ट करून
व्हॉट्सअपवर
टाक.
मेसेज टाकतो तुम्हाला.
मला व्हॉट्सअपवर ग्रुप आयडी टाक ना मला आपला. मी असेल
ID.
त्याच्यात रे, मी आहे, पण कधी कधी सापडत नाही तो. चला मग ठेवू का?
ओके सर, ठेवा. हरकत नाही, हरकत नाही. काय असेल तर मी
चालेल.
तुम्हाला कळवतो. थँक्यू सर.
ओके ओके, फाईन, चालेल. थँक्यू.